So we will start today's classes within a few minutes. Please wait. So first of all, I would welcome all of you to this live interacting session. So and this is our last live interacting session of these courses, Conduction and Convection Heat Transfer. So we have already covered up whole the syllabus, and today's classes we will discuss about some of the concept that has been yet to be. So the thing is that in the up to these last classes, what we have discussed is that we have discussed about this fundamental concept of boiling and condensation, and after that, heat about the concept of the heat exchanger. So regarding this, I hope that all of you have gone through these courses that has been delivered by Professor Chakraborty and so, and this courses is quite vital if I consider your academic purpose, like if some of you are going to work in a project based on this real life scenario, so you will have to deal with this concept of heat transfer. That's why this is quite essential. And also in these courses, the main purpose is to give you the lesson about the basics and the fundamental that you could incorporate easily in any problem. Okay, and to understand why such phenomena is happening and what is the reason why convection is happening, why conduction is happening. Okay, so this is the last class I will be taking as a TA. I am Niloy. As you know that I am I'm a PhD student in IIT Bhubaneswar. So I will I hope that you all of you has gone through the life integrating session that I have already delivered till now. So the exam is on the 25th April. So I hope that if some of you are interested in sitting for this exam or have enrolled for the exam, so please go through this interacting session, because there we have discussed many numerical problem, how to approach such problem, and the question will be around such types of fundamental or such types of concept. So that will definitely help you in this regard. Okay. So this class is the extension of the last classes, where we will initially discuss few questions based on the heat exchanger. Already the concept has been discussed in the last classes, right? So beside this, we will discuss about some of the important topic that you need to learn about these courses, and also important based on your exam point of view. So that will be my approach for today. And also I have some doubts. I have got some doubts from the students. So that also I will elaborate in today's classes. Okay. So if you have any confusion, please let me know before starting today's session. So I'm giving you 1 minute. You can send mail or you can also use the chat box. Okay. So first we will recap what we discussed in the earlier classes. So in the earlier classes we have discussed about this parallel flow heat exchanger where both the fluid on the hot side and the cold side are flowing in the same direction, and this is the chart that we have already discussed in the last class, right? So just a minute. So this chart we have also discussed in the last classes. This is for your parallel flow, and for the counter flow this is your temperature profile. So in the counter flow what we have observed that if in the hot side it is both these profile are in the are looking like the same but the direction is different, and in the parallel flow though the direction is same but the profile is almost inverse. Okay, and also the fundamental concept that we need to remember either in hot side or either in cold side, the amount of heat transfer should be same because we are considering the heat exchanger to be adiabatic, that is no heat loss from the heat exchanger. That thing we have already discussed, right? Also, we have studied about this overall heat transfer coefficient U. So how to find out this U also we have studied based on this concept of your thermal resistance. So for this conduction, if there is conduction, you can use the thermal resistance formula of conduction. If convection like this way, and this is the approach you need to follow. And for the fouling factor also, how to find U, we have also discussed about this thing, right? And also we have derived about the mean temperature, which in case of an heat exchanger we consider as an LMTD. Okay, so this LMTD what we have got, this is del T2 minus del T1 by ln del T2 T1. So what basically del T2 and del T1 is? So if you draw the profile of any, either be it parallel flow, be it counter flow, that means the temperature in this end is 1 T1 and in another end it can be T2. So that T1 T2 depends upon you. You can take this one as a T1 and this one as T2, or inverse you can take. This will not affect the result because if it's come in actually remember one thing, whatever the value it is in mod value, always we take this as mod value. That means if inside there is a negative, it will be converted into positive value, right? Also we have discussed about this NTU method and this LMTD method. Why we will be using this LMTD method? If our criteria is the design parameter, then we will use this LMTD. Basically in LMTD we will get the area, which is the design area we are getting. And in case of NTU, actually our main purpose is the rating, how much effectively the heat exchanger is going to work. That thing has been represented by your NTU method. So that is the basic fundamental difference between these two methods, right? So that thing also we have discussed. And after that, in the parallel flow and the contour flow, we have discussed about this condensation and boiling, right? So, say in this tube, if saturated vapor is flowing, and in the shell side, the cold liquid is flowing. So what we'll observe, because actually it is in a saturated vapor, so if it comes in contact with the cold fluid, so it will change its phase from vapor to liquid, but the temperature remains same until and unless it is getting fully converted into liquid. So that's why in this curve the temperature profile of the hot side is constant, that is 100 degrees C. So but the cold side is taking heat from this hot body, so that's why its temperature is getting increased. So that's why you see this curve. Okay, so similar thing you will observe for this contour flow or the cross flow. So here you see that if it's a saturated vapor and if it is flowing through this tube, and at the same time if the cold water is flowing from the other side, the similar phenomena will observe. So it's just an inverse curve of this one. just the direction is basically different. Okay, see, the thing that I have discussed in the last class is that this TCO can be greater than TH1. Why? Can you tell? What I am saying that if this TCO greater than THI, what it indicates? It indicates phase change happens. So where this phase change is happening? It happening in shell side. Okay. So that's why there can be a criteria that this graph can move like this way. But if it is happening in such a way, then what you will see that this temperature profile initially remain constant, and after that all of a sudden it decrease. Okay, have you got this thing? Because our main motto is that whatever with the heat lost to the colder side, that should be the heat gain in the sorry, what should be the heat lost or heat gain by the cold side, that is equal to the heat loss by the hot side. Any confusion? So in the if I talk about this, okay. So if I talk about this control flow or whatever flow, basically this del T1 del this difference. If you take the difference anywhere, that is your del T. So LMTD, you got what is del T? This one is your del T. Del T in one you can take on the left side or you can take in the right side. Please remember this thing because that will help you to solve numerical. Okay. And another thing is that in case of counter flow or the cross flow, just a minute. So this LMTD derivation, what we have derived is basically from this parallel flow, right? If you recall this thing, how we derive this thing, we have derived from this parallel flow. Okay, but in case of parallel flow, but in case of counter flow or the cross flow, what will we observe in case of the counter flow? The thing is that basically in the LMTD, whatever with the LMTD value you get, it should be multiplied with a factor or a constant. Okay, so that is called as the correction factor. Say this formula, this LMTD, if I use a formula correction factor, say F, if the LMTD value comes, say the LMTD value comes at 5, okay, so there should be a correction factor, say this correction factor is 0.01 or like this something, 0.09. So this is basically a factor that will help us to give a better representation because the flow is in the opposite direction. So the phenomena is a little bit different. So that difference, that little bit difference in the phenomena has been represented through this app. Have you got this thing? That means if it is a counter flow, there is a if you calculate the say the condition, both the condition in the parallel flow and the counter flow are same. Like the inlet temperature, outlet temperature, both are same. So what you expect? You expect that the LMTD value that you calculate from the from the parallel flow and the LMTD value you get from the cross flow or the counter flow are same, right or wrong? But in general, because as the flow is in the opposite direction, so there is some extra phenomena that is you that I can talk about this turbulence phenomena and other phenomena that is a little bit of more, or that is a little bit of less compared to your parallel other flow. So that's why we have used a factor f, so which count all other external parameters that we haven't counted in the calculation of the LMTD for counter flow. Okay, so I am giving you a numerical question, so please try to solve. Just I am doing. Say this is a vessel. Okay, the steam is entering. You know steam, that means vapor. It is entering at 30 degrees C and it is exiting as liquid. Say this is a tube. This type of tube is there. Say it is at 14 degrees C. This is 14 degrees C. This liquid is coming out at say 22 degrees C. Okay, and because the steam is higher temperature, so when it comes in contact with the colder water, it get what will happen to the steam? Ayush, what will happen to the steam if it comes in contact with this cold water surface? It is at height, so it will condense, and condensation is happening at what temperature? No, condensation is always take place at the same temperature, because if phase change is happening at constant temperature, what is the temperature? It is at 30 degree. So the outlet liquid temperature is 30 degree. That means condensation is happening at same temperature. You got it? Hmm. So if in the question another thing is given, surface area of the tubes is 45 meters square. Okay, and U overall, that means overall heat transfer coefficient is given as, so first question is that find mass flow rate of the cooling water. Okay, next is the rate of condensation of the steam. Have you got this question? So what basically in this question they have asked, Basically, they have asked to find m dot c mcp delta t na m dot cc del t. So in this, you just have to find mc. Okay? Any confusion? Huh. So what is water? So what should be the cc value of water? No. This 1.0, you are talking maybe most probably about density, not the specific heat of water. 4200. Okay, I'm giving. In the question, maybe most probably they will not get. This is cc of water is 4200 joule Kelvin. Okay, is it clear? Now the question is clear or not? Please let me know. See, sometimes if the value it is not given, or some in some cases what will happen, they will provide you with the steam table and all these things. In that cases also you can find out. Uh, and another thing, say they in the question it is given. If it is not given, you can assume yourself HFG, because steam is converting into liquid. So there should be latent heat of enthalpy. So the latent heat of enthalpy, it is at 2450 kg kilojoule per kg. So up to this, the question is okay or not? Please let me know. Ayush, is it okay? So first what I need to do, I need to draw the profile. So hot side, which one is the hot side? Any side. Say this steam side this is tube side I am considering. So which one I will consider hot side? This one is hot side, right? So this is your TH1 and this is your TO. So the temperature is constant. You can take any side, it is not an issue. THI. Okay. Now, so in this question, whether anything is given, let me check one thing. So tell me whether it is a what type of flow? It is parallel flow or counter flow? It is how? See, if the flow is flowing in this direction and after this in this direction, the liquid is also flowing in this direction. So it is almost parallel flow na, or wrong? Check. So what do you think? Just I'm telling. Can it not be parallel flow? No, it is not a parallel flow. You are right. Why? Di direction of flow. You can't say, see, only in parallel flow you will directly see that these are flowing in a same line. If it is not in a same line, irrespective of the situation, you can consider it as a contour flow. And in steam problem, in any types of condition where such certain types of lines are coming, you can consider it as a contour flow. Okay. So see, there should be a temperature profile, right? So this is what, so this should be your T C O and this is TCI, right? You can draw yourself on opposite side also you can do it. This is not creating a problem. So what basically your del T1, just tell. Hmm. First tell in terms of T. T C O. That is 30 minus 22. So that is your 8. And what is del T2? 30 minus. Hmm. See, before starting such types of question, in the exam you just write assumptions. What are the assumptions I have taken? Just now I have said that it is a, also you can write it is a steady state, right now, and no heat loss. So maybe many other assumptions are there, but write at least two, three. No heat loss. Okay. And properties are not changing with time. This is also another condition. So both these del 2 are coming. So I can find out now LMTD. So that is basically your del T1 or T2, whatever you want, you can write. So tell me what is the value coming through calculation. 11 point. Okay, let us take 11.5. Okay. Hmm. So now in the question MC they have asked us to find. So we know what we know. We know basically Q heat is MC CC T TCO minus TCI, right? Is it correct? Q equal to MC TCO minus TCI. And for hot side, MHCH TCO TCI minus THO. Say I am just writing this thing, but it is not applicable here. Why I am saying this thing? Thi minus Tho. In the given cases, either heat loss is because say HOI and HO both are, that means no heat loss. Is it the scenario? No, no. How? Because heat transferring is happening na. This formula we will only use if it is below boiling point or the condensation point, right? Because at this point the heat transfer is because of your specific heat. But as here it is a phase change phenomena, so heat transfer is because of your latent heat. So for latent heat, the heat transfer formula is m dot h LV. That is the formula you have studied, right? So all I have to find out the m dot c, and see this value is given HFG, sorry, whatever you want you can write. HFG is given, so you need to find m dot h. That means either you need q dot or hold this value. So area is given, okay. So I can easily find q equal to u a, right? So what is the value coming? Please let me know. U is given, area is given. Calculate q dot and after that find m dot c, m dot h. First tell what is the value of q after putting all this value. Haha. Yes, yes. 108. 250. It is in what is the unit? What most probably. Okay, this is the q you are getting. So can you find now m dot c? So tell me the value. If you have to convert it into kilowatt, you can easily convert 0.25 kilowatt. So it doesn't matter. You can write anyone. So tell me what is m dot c coming. 32 kg. Yes, near about step 7, sir. It is in 32 point. 32.32 kg per second. For cold, and what is for steam? Okay, just calculate. Huh. So see, first thing is that you can assume yourself or you remember these values, because generally for water maybe they will not give, but for any other fluid they will definitely give. Okay, because they expect that the student remember this formula of HFG and CC. And if you forgot this thing, you can assume nearby any value and just write in the assumption, assuming HFG equal to this. So if your assumption is this one, then the teacher will give you marks, full marks. Okay. So see, in sometimes in the exam, you may forget this value. Say you do not know a specific property of a fluid, so you think that the examiner will not give you marks. So that is not the right. You just write assuming h equal to this value, near about some value. You know that it is more than 2500, so you can write 2500. And after that you can do the calculation, whatever with the result comes, maybe that will not matches with the exact answer, but as your approach is correct you will get 90% mark, 80 to 90% mark. So it is a, if it is a 10 mark question, you will definitely get a minimum of 8 marks. Got it? Yes, yes. And if it is C, I have given CC as 4200. What is CH if it is not a phase change problem? It is a single phase problem. Then CH and CC are almost same if it is not given. So it's up to you. Whatever the value you are taking, it's up to you. Just assume this thing. A little bit mistake. Why? See, it is in kilojoule. Kilo means into 10 to the power 3. So whatever answer you will come divided by 1000. So it will be 0.4. Yes. You got the mistake? Another mistake? Okay. Okay. And another problem I will discuss right now. 'A similar types of question. This is directly a heat exchanger I am drawing. 1.2 kg per second. What it is? this is mass flow rate. Okay. This say 2 kg per second. And the diameter is given, diameter of the pipe is given as say, any confusion up to this? Anything you can't understand from this figure, please let me know. Diameter D. So this is what? 1 minute. Hmm. So in the question they have asked you to find the length of the heat exchanger. So the length of the heat exchanger they have asked you to find, and given U equal to 640. So that is the value they have given. You asked to find length of the heat exchanger required to achieve the desired heating. Is the question clear to you? It is not given. So you can find out now. Cannot you find out? So first, what is your what is so see, what is your approach? Just tell me what is your approach? Huh, 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 huh. Yes. Huh. Hmm. 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 So first, what is the first step you say? Huh. Heat on the cold side. Okay, that means inside this tube you're talking. So what would be the value? Q dot equal to MC C TCO minus TCI. So MC dot is 1.2. What is CC? You can take 4200. And this one? So what is the value coming? 302. Hmm. What? Okay. Now main thing is that to find out the length you require area. Area you get from this formula Q equal to UA LMTD, right? So you required LMTD. So LMTD comes if I know the port temperature. But the port temperature is not known. How you find out this port temperature? It is M dot H C dot H T H I minus T H O. So Q dot is already I know. M dot, what is M dot H? C H? Okay, it's up to you. It is not necessary to be same, but if you assume right in the font, if you do not assume this thing, marks will be reduced. Okay, minus. So what is the THO coming? 1, 124. Okay, so that is the value you are getting. So now from the LMTD, what type of flow it is? Uh, So what will happen if I draw the profile from start from here? First say this is for the tube in this cold side. So if it is TCI, its temperature will increase TCO. And here the cold is starting, right? Sorry, hot is starting. THI. And its temperature is THO. So these two difference and these two difference are del T1, del T2. Del T1, del T2. So anything you can take. Say I am taking TCI minus THO and this one is. See, one thing I have done mistake, the THO should be on the above. Okay. Yes or no? Yes, sir. No, 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 no. Answer will not change, but negative sign will come na. So it will not be good. THI. And physically it will be wrong na. Not numerically wrong, but physically it will be wrong. So try to draw this temperature profile along the question, because then the examiner will see that you have understood the concept. So if somehow the numerical you do not know the value or there is any mistake, you will get marks based on your solution. THI minus TCO and THO minus TCI. So what it would be? THI minus TCO, and here 104. Okay. So now find the LMTD and let me know. Okay. Then you have to find Q, sorry, you have to find area on this formula U A LMTD. So find AS. Yes, yes, by DL. And then find L. Length is 109 meter. Okay, good. So you understand how to solve this one? Please check the units, whether it is in meter, centimeter, and all these things. Always check for this one. Okay. Hmm. So this is some of the numerical concept. I hope that if numerical question comes, you will be able to answer, right? So see, I have talked about a factor F. It is counter flow. but there is no f. In some question, maybe the f value is given. At that cases, to find q, you have to use this f here. You find the LMTD in this way. Say f value is given 0.9. So here you need to multiply it with 0.9. Okay. So there will be the difference. If it is not given, not necessary to put. If it is not given, we assume that the f value is 1. So next thing. So this first question I have already discussed. Huh. So try to answer this question. I'm just giving you 1 minute because you have to recall all these things. Considering this thing, I'm giving you 1 minute. It can be a multiple answer. That is my hint. Mhm. A, B, and D are wrong. Let us check. So first is that the definition of the effectiveness can be physically perceived only with respect to a parallel flow heat exchanger. No, the effectiveness can be for both types of heat exchanger, right? So let us see. So the first option is wrong. So in the question which one is wrong, it is given. So A is your wrong answer. So B is also wrong. The definition of effectiveness can be physically perceived with respect to both parallel and counter. It is correct. So that will not be the answer. The effectiveness is only for parallel and counter flow, not for. So it is also wrong, right? What is the formula of effectiveness? Q by Q max. Yes. Q by Q max. What is Q max? What mixing temperature means hot inlet minus cold inlet. So what is C mean? C mean that means your M dot C hot side M dot M dot C cold side. Which one is the minimum? So that would be counted here, right? Hmm. So if I ask you a question, effectiveness depend on what? Huh, almost, huh? Not NTU. NTU is a part of effectiveness. It depends on NTU. It is one correct. Another? Area in the sense, not directly area. Just think and let me know. What type of problem it is? Just tell me this thing. Answer is hidden here. Heat exchanger. In the heat exchanger, what happens in inside an heat exchanger? My question is what happen inside an heat exchanger? Basically, there is a flow, na? Now got it? So it depends on the flow also. Just a minute. Let me check one thing. Though I think in this question, so which books you are following? Which book you are following? Any book? That is even good for your academic purpose. That's the best thing. Just a minute, I'm not getting one thing. I have to check because the word perceived, the definition, so that is creating issues. Hmm. Hmm. Yes. So, any, I didn't get your point. Huh? No, that is not the thing I am saying. So my confusion here is that the definition of effectiveness can physically perceived only with respect to. Uh, yes, actually this thing in the option B will not be the answer. Tell me why. Option B is correct. Why? Actually, if you recall the effectiveness is basically the rating parameter, right? So in the rating parameter, we require maximum power. So maximum power is basically hot inlet minus cold inlet. That is the difference. But you see, in case of this is your HI, this is your TCI, right? So the difference here is, here the difference you please observe, THI, this is TCI. So my question is that the difference between here it appears to be more, right? Yes or no? So the Q max would be more. Here the TH and would be small compared to this case. Yes or no? So that means if these two values is small, that is Q max is small. So efficiency, if Q max is small, what should be the efficiency? Efficiency, and if it is large, then efficiency will decrease. So in this regard, what that means? That means for your counter flow, this principle of effectiveness is better. So that's why option B is the correct answer. It is because can be physically perceived. It is talking about the physical meaning, not applicable. Though it is applicable for both heat exchanger, but physically it is important with respect to counterflow heat exchanger. You got my point? Because it is asking about the physically which is important. But if say that it is applicable, the definition of effectiveness is applicable in this thing, then your answer was correct. Okay. Applicability is everywhere, but physical importance is mainly limited to counterflow. So I'm moving to the next one. So please check. See, if you still have any confusion, you can do one thing. You can go through the courses lecture now 63. In the lecture now 63, this concept has been explained in details. If you still have some confusion, or if you find that I am not getting this thing, you can go through the lecture, or even you can contact me. Okay. So now try to answer this one. Hmm. Ayush, what do you think? What will be the answer? A few moment, if just 10 to 15 minute backs, you have solved a numerical. So I hope that you would be easily able to answer this one. Any idea? C is correct. Yes, it is correct. Hmm. Huh. Huh, yes. Uh, Means talking about the value of C. CC. So see, in general scenario, you see that for if I take for water, what is the CC of water, and in case of forgot about this thing. Uh, Generally, if here it is said for condensation process. For the condensation process, uh, either CC is required. So in the condensation side, the heat transfer from the cold side, the cold side is taking the heat, whereas the hot side is only just phase change is happening. So which is taking more amount of heat? Because in the if I talk about this condensation side or the cold side is basic in the cold side single phase heat transfer is happening, right? So there is a significant temperature drop because it will take up the heat from the condensation process into the hot fluid. So the specific heat of the cold fluid should be small, right or wrong? Because the temperature of the liquid remains same, only the latent heat of condensation is getting heat is extracted from this latent heat, right? So that's why first option is a wrong option. Okay, let us check with see this is B. The specific heat capacity of hot fluid is small in comparison to cold fluid for boiling process. Now in boiling process, the reverse thing. That means here in the hot side, so boiling is happening. Say boiling is happening outside the tube. Okay, or what I can say. Huh. Boiling is happening outside the tube. So what is flowing inside the tube? Hot fluid. If this is a tube, so this is boiling is happening here. So when will the boiling happening? If the fluid in this part is hotter than this, right now, C of H. So boiling, though it is boiling is happening, but the here it is your cold cold side na. Compared to this side, it is cold side na. So if the cold side Cc is higher than this one, then only boiling will happen. Because we know that boiling take place if the surface temperature is more than the liquid temperature. So that means that the Cc of the hot side should be more or small. Just a minute. Let me compare to the cold fluid for boiling process. Okay, okay. Just I got this thing. So the thing is that okay, just a minute. So I am just giving you the concept to give you explanation regarding this. So basically there are two types of heat. One is sensible heat, next is latent heat. Okay, what is the difference between these two? Sensible heat basically MCPU delta T you have studied. So in the single phase, the heat transfer is mainly because of sensible heating, and for phase change, it is because of this one. You know this thing, huh? So so if I talk about condensation or boiling, so what is the main thing? T remain constant. So heat transfer is because of your phase change. So Cp is required, not required because Cp is for sensible heating. So Cp is required or irrelevant, right? Up to this, any confusion? Or I can say that ignore Cp. Hmm. Ch will also not that much required, but the question is that Cp is not required, right? That means Cp is very small. Yes or no? So Cp not required means Cp is very small compared to HFG. Okay, no, not Cp. I can say that sensible heat. Better to not to create confusion. A sensible heat is very small compared to latent heat. So if the sensible heat is very small, that means Cp is very small, right? So that's why option B is the correct answer, but it's a which it's a correct answer. Similarly, but option A is the wrong answer. So it is the correct answer here, correct option here. Sorry. Got it? So it is a little bit confusing question. Similarly, exit temperature of the cold fluid may be higher than the hot fluid. It may be possible because we have discussed in the earlier classes. So option A. Now this question. Why? Hmm. Hmm. Yes. So based on which principle it is working? Actually, it is working on this principle Q equal to UA del T, right? So if say all other conditions are same, so if you increase area, thin surface means area will increase, right? So if area increase, Q will increase. So option A is the correct answer. Good. Also the fin effectiveness will. So that's why you see in the AC or the radiator in the car, you will see that's why fin type structures are there. Hmm. Respirators. So actually, it's basically the heat exchanger where there is a separation of the two fluid flow. Like there should be wall between these two. Say one is tube side, one is shell side, right? So this is basically an heat exchanger. So I am just giving you an example. Say a river, not river. Say a small model of a river-like structure where through a small channel water is flowing, hot water is flowing. Okay, and above it the cold water is we are blowing the cold water, cold air. Okay, so what will happen? The heat transfer will be taking place. So that means basically it will also be an heat exchanger. But that's why they have distinguished this thing from the common scenario where this reciprocator type heat exchanger is such types of heat exchanger where there is a wall separated for this fluid flow. Okay, and it should be a steady operation. Got it? Say tube. If I talk about this tube, inside this tube, hot fluid is flowing. Outside the tube, cold fluid is flowing. So because of this conduction, the heat is transferring, and after that, convection. Got it? Yes, yes. We can. Uh, yes. Very good. You got it? Uh, Next. I think you will be easily able to answer this one. Yes. So no. Why? True or false? Uh, uh, mhm. For rating problem, only NT method we use for rating and not rating problem. We use only the okay, okay. Just what you are saying, which is the answer option? How it is if the rating problem of the heat exchanger basically we have to incorporate this effectiveness. So for this effectiveness, only NTU is used. Uh, Hmm. Okay. So in this question, the arithmetic average temperature can be used in place of logarithmic mean temperature difference for almost all practical cases for heat exchanger without much error. What is saying that we can take the average value in place of logarithmic value that will give a less error. Is it true? So answer will be false because if I use it is the energy balance equation because we know that this LMTD where we have derived this LMTD from this temperature profile graph we have taken a small domain and from this small domain accordingly we have derived how the heat is flowing through this small area, right, from the cold side to hot side difference. So it is not like that only taking the average will give the same scenario because the temperature is continuously changing. So taking this average may sometimes gives good result and in close with respect to this LMTD, but in general it is quite different. Okay, or there is a much more error. So that's the option B is the correct answer. So next question. Okay, acha. Just a minute. Let me tell you one thing. Actually, I have done something. So rating problem, though in this question say it is a rating problem. So what type of rating problem? Rating problem basically is two types of problem: area rating and power rating. Okay. So it is not given whether it is area rating or power rating. That's why both these two rating. So for why this answer is false. This is because if it is area rating, then we have to use iterative method, and if it is power rating, we have to use NTU epsilon method. So it should be clarified whether it is area rating or power rating. So now try to answer this one. So see first, just tell. Huh, huh, huh. Yes, very good. Huh, we do not require this. Very good. Huh, So option A, very good. This is how you need to analyze this thing. Okay. But remember one thing, rating problem in general rating problem, if someone talks about this rating problem, it may be area rating or power rating. But in general scenario, if it is talking about the counter flow heat exchanger, then rating problem means power rating, because this NTU method is good for counter flow heat exchanger. Can I move to the next one? So from heat exchanger, this is the last question. So please try to answer. Okay, let me clarify this thing. Wait 1 minute. Just 1 minute. Huh? So what is your question? Okay. So basically, if I talk about a regenerator or and next is the previously I have discussed about the recuperative heat exchanger, right? So what is there here? There was has a certain flow path for each fluid, right? And the heat transfer is taking place through how the heat exchange is taking place there between the in the I am talking first. Tell me about the recipurator. I am thinking how the heat transfer is taking place. How? Mm. Through tube, yes. By when the what is the mode of heat transfer? Okay, by conduction and convection. So basically, both these two fluids are flowing continuously, right? But in case of a regenerator heat exchanger, what basically it is, here the heat is stored, is a temporarily stored in a body. Okay. Uh, so how I just if I have to give an example, uh, like in real life example, any real life example. Huh. See, I'm just though it is quite tough to give you a real life example, but still I am giving you an example here. Say this is a fan. Okay, this fan is moving like this way. So this is an inlet. this is an outlet. Okay. Similarly, say here cold air is flowing and here hot gas is flowing. So as the hot gas is flowing, so what it do? It will recirculate, right? The fan, what this fan do, or is it's a type of fan. It will recirculate this hot fluid. So there is a say mm, there is no direct contact. So what will happen because of this hot gas? This fan will start to moving. Yes or no? So as the fan is moving, so what will be coming out? Because force convection, the hot gas is giving, hot gas basically means whatever energy it is carrying. Say hot gas means it has certain energy it is carrying with it. Yes or no? So once it is carrying it, if it strike this blade of the fan, what happens? It is getting converted into mechanical energy. Yes or no? So because of this mechanical energy, the fan started to rotate. So that means the from where the energy is taking, the energy is taking from the hot gas. So in return, what will happen? In return, the temperature of the hot gas will reduce and these gases will become comparatively cold, right or wrong? So similarly, in this way, I am just flowing this cold air, right? So as the fan is moving, so the because of this hot air, it is moving, so it is generating heat. So once the cold air is moving, so the cold air will take up this heat from this what I can call from this fan or the body of the fan, and that's why the hot air will come outside. So mechanism you understand. So the heat, where is the heat stored? Here, the heat is stored in the fan, fan body or this rotating wheel. So it is a temporarily store the heat, and and after that it will transfer the heat to the cold air. You got it? So maybe the thing can happen that initially, once the hot gas is flowing, it will started to uh, gain this energy through this mechanical form, and after this, once it get the certain amount of energy, then if you give the cold air, then it started to convert it into the hot air. It's like the mechanism of the heater used in our room. Not directly. The above one is the mechanism of the heater. So in the heater, what will happen? Okay. Almost similar, not that the example. So that is your regenerative type heat exchanger. So huh, yes. So actually there should be a temporarily storage body. So it will not be a direct heat transfer. Okay. So that is the fundamental difference. Well, if I am just giving you an example, another hint, like say in a time t equal to 0, if the mm, in case of normal heat exchanger, what will happen if it loses 1 degree of heat? Say consider the mass flow rate and all other parameters same. So if the hot side fluid releases 1 degree of heat, so the cold side will take up 1 degree of heat at that moment. So I am considering all other parameters same. So but here if the hot gas is releasing 1 degree of heat, it will not instantly transfer to this cold air. It will take a few time to get convert. So that is another difference. Okay. So try to answer this one. So which one? So you are saying option A is true. Yes, good. Option B, why? No, the fluid cannot be allowed to flow simultaneously. It will at a later time, na. So, so there will be temperature gap. So say to make it more easy for you, in case of flow, the regenerator type is always alternatively flow, but the recuperator type is flowing simultaneously. Okay. So in case of heat storage, the recuperator type, there is no heat storage body, but in regenerator there is a heat storage. Okay. And medium, if I talk about this medium, this recuperator type, uh, what will happen? Actually, the heat transfer is from a fluid to fluid through a thin solid pipe, right? Similarly, in the regenerator also, this heat transfer is from fluid to fluid, but the solid here plays a vital role. So this regenerator type you have seen in the gas turbine, okay, and this tube and tube type or the shell and tube types are the example of recuperator. So option A is correct. So either option B is correct. No. Option C. There should be a storage capacity. So option C will be correct. High storage energy. So option D is not correct because a low storage energy. If it is a low storage energy, that means it will transfer the heat. So where it will transfer the heat in case of your recuperator type, the thin wall basically why it is used because it can easily release the heat. Our objective is to release the heat, not to accumulate heat in case of an heat exchanger. हाँ, hmm, हाँ. Uh, no, it is the storage capacity. That means, say, if I talk about the gas turbine generator, what basically, as the gas is flowing, so it strike the turbine blade, so the turbine is started to rotate, right? So as it is started to rotate, it will generate energy in form of electricity, right? So it is a storage body. The turbine blades are the storage body. It have the capacity to store huge amount of energy. Okay, got it? So I am moving to few things that is required. Like one of your before going into other things, you have one doubts in the last classes. What that was? Some curve. Hmm, has lecture. Yes, yes. So just see, this lecture is not that much important, but as it is given, so let me recap it in a short time. So before Hassler chart, you have gone through this lecture of lump heat capacity, right? I think you have gone through it. So in the lump heat capacity, basically a small body is there where we can, it's like that the heat is instantly getting converted at a small frame of time, right? It is for the solid body. So what we have considered, that if there is a mm, convection, if it is HA T infinity minus T, it is infinity. Say I am considering this T infinity is more than T, right? So that is because of your heat transfer in the body at a small time. This is because of your convection. And if I forgot, there is no heat generation, no conduction effect. So I am ignoring this conduction effect. Okay. So from a body, the heat is directly transferring to the environment, or the environment is directly. Okay, I just write it T minus T infinity. That would serve the purpose. This is T minus T infinity. Okay. So that is basically I can write rho V C dt by small t, because there is an instant, this one is your transient term. How much the temperature change is happening in this region, that is directly getting converted into this convection, assuming this conduction effect is negligible. That is the thing we have studied in this lump heat capacity. Okay. So also we have studied about this theta. What is theta? T minus T infinity. So if I write theta initial, that means Ti minus, right? So what exactly theta? If someone told about theta, basically it is the temperature difference at time t. So if I say temperature at time t equal to 0, that means initially 0, because T infinity is already fixed. So only the variable here is T naught, right? Up to this, any confusion? Hmm. So also you have learned about this, what is this? Biot number. What is Biot number? Biot number is your, if I write the definition, it is basically the convection resistance within a body by the conduction resistance within a body by convection resistance at the surface of the body, right? So the conduction resistance is basically within the body, but the convection effect is on the surface of the body. Please remember this thing. Okay. So if I talk about this resistance, but if I talk about only convection and conduction, so from this formula you see that the convection is on the top part. So that means the convection of a body at the convection at the surface of the body by conduction within the body. So do not get confused about the convection and convection resistance. So both are inversely related, right? Also the, you know, the characteristic length and all these things you have remembered, I think. Okay. So the thing is that actually to study this transient, after solving this thing, an equation will comes, and also the Fourier series. I think you have studied in maths. Yes or no? So in this Fourier series, from this Fourier series, If I write this Fourier series, basically it is t minus t infinity by ti minus summation n equal to 0 to n. So it is basically solving this thing. Solving this thing, so a big no need to remember this thing because this is a common equation. We recall this thing because we are working on this one. That's why e to the power minus lambda n square alpha t by L square. This equation is not required, okay? Just I'm writing for your understanding, okay? So these types of equation you will get on deriving this thing. So can I write this part only as theta by theta I? Yes or no? So actually a graph, this Hessler chart is basically few graphs. So one graph is basically with theta by theta I and this value L LT lambda t by L square. Okay. So this lambda t by L square is also known as Fourier's number. So this is a graph we can plot using this thing and only this thing. Rest other are constant. Got it? So now the thing is that this number comes from this concept of your what is this concept HL? Where I have written here. This is your Biot number. So with respect to a given Biot number, if you draw the line, say Biot number is 0.01 or something, so you will get a curve. This curve should be look like this. Okay. So the slope basically here is k by HL. Got it? So why this is important? Say it is a graph now. You have will got this chart graph in a datasheet book. So at a certain value, your Fourier number is given. Okay, and also Biot number is given. Fourier number is given. Biot number is given. So if the Biot number is given, you will know which line is this one corresponds to a Biot number. Which line is this is not the Biot number. This is the inverse of Biot number. Remember this thing. Okay. So if you know the Biot number is this much, so you can find out which curve is corresponds to this value. Yes or no? So if it is known to you, forget about this step. So you can find out. Say you know the value is this one. So you know the Fourier number and Biot number. So you can find out this point, right? Accordingly, you can, if you know this point, accordingly you can find out the value of theta by theta infinity. Yes or no? Theta by theta. So already T infinity is known to you, Ti is known to you. So can you find out T? So that's why this curve is essential. So this is one curve with respect to your Fourier number. Next, another curve is there where this one is theta by theta 0 or theta infinity, theta I. This one is same, initial or 0. Whatever you want, you can write. This is not an issue. This is k by HL. So here it is the slope. Now here k by HL comes here. Now the thing is that at that cases you will observe the curve should be something like this one. So this is x by L. What is x by L? This I'm just forgetting to tell you. If this is a flat plate, okay. If it is its length is its thickness is L equal to length equal to this one. So x basically means how much distance from this one. So what I know, if this is a heated plate, it will directly transfer heat through convection. So conduction effect is negligible, right? So that negligible conduction effect, if I have to check at a certain value of x, say you know this x by L value, mm, say for a given thing, x by L is known to you as 0.1, right? That means this value, this point is known to you, okay? You know this biot number. Biot number is also given. So corresponds to a given biot number. You can draw a vertical line. The point where this vertical line touches this value, it will be your desired point. So at this point, if you draw an horizontal line, what you will get? The value of. Uh, so accordingly, you can find temperature, right? So similarly, this is for theta. Also, there are a graph for Q. I am just drawing also that graph. So it's just to solve numerical question based on the graph. Considering at least 2 to 3 value needs to be given. Similarly, there is a graph Q by Q naught. How much heat transfer initially by at a moment. So that thing is given by, if it is for a Biot number, okay. Directly here in the first slide this was Fourier number and here it was Biot number. So what this graph do? This graph is a combination of both these two. So how it changes with this thing that has been given here. After that, after a few moments, it is coming like this way. And here, this is your HL by K, which is your Biot number, right? So if Biot number is known, and if you know a value here, so say here it is the required Biot number. So you can draw again a vertical line and corresponding line. So what you will get the heat loss Q you will get because Q naught is known to you. So you will get Q. Yes or no? So this is the significance of Hessler chart. Is it clear? Okay. So what is important for this exam point of view? I'm just giving first is this 1D conduction equation, how it has been derived. Please look into this. Okay. This thing please look, and also the numerical like from the 1D conduction equation how to solve with variable area or like with integration and derivative. This numerical question, this is very important because this first 3 to 4 lecture is quite important. If you follow this lecture, I think you will be able to attempt 50% of the question minimum. Next is I hope so. Lump heat capacity is also important, not directly conduction. Lump heat capacity is also important. A question will come or a numerical will come from the Biot number. So if the Biot number is less than 0 point, then it is not as a lump heat capacity. So in the question it will get given. So check whether it is a lump heat capacity or not. So that thing you need. What is the definition of Biot number? What is Fourier number? What is Nusselt number? What is Prandtl number? What is Rayleigh number? Next is Richardson number and its significance, the Grashof number. So what is only definition is not required. You require the physical significance. What, next is you remember one thing we have discussed about thermal resistance, right? So this thermal resistance is also important. In the thermal resistance, thermal diffusivity, thermal diffusivity, that is also important. Now coming to this convection, in this convection we have solved some numerical problem from conduction, how conduction equal to convection. These steps of numerical we have solved, right? So another important thing, this Reynolds transport theorem, which you most of the student face it tough. In the Reynolds transport theorem, if I write this equation, please remember this equation. This is a general equation. So in this from this Reynolds transport equation, uh, before this Reynolds transport equation, why we are using Lagrangian and Eulerian approach to convert a control volume into a control mass, a control surface into a control volume approach, right? So these are the thing where n is the property. So what are the assumptions? First, in the question will come say derive this uh, this equation from this equation. Well, using this RTT equation, derive this mass conservation equation. So that will be quite easy because you have to take n equal to m. So this small n is basically m by m mass per unit. You just put it here and you can derive. So that is an important concept here. Okay. Yes or no? Next is the even this from this boiling and condensation and what is the difference between the drop wise and the film condensation? A derivation is there for the condensation. Please look into this. Okay. So, uh, what is the main difference that is required in coming to this boiling? So, see what, about this Leidenfrost point, about this Nukiyama experiment, and that the Nukiyama experiment is not able to find out this transient boiling curve reason, and all these things. Please look basic concept. Okay. And apart from this, in the heat exchanger, and that I have already discussed today. So, any more confusion? So, can we wind up today's class? So, I hope that this is our last class for this session. So, though these courses is quite new to many of you, but still, I feel that this course is vital for your academics. And if you have gone through these courses, you will definitely enjoy these courses. At least the fundamental concept you will understand. So that will definitely help you to crack many interviews. Even if you are planning for any placement, that will definitely help. And uh, just do not define a term. If I talk about someone asked you what is Nusselt number, do not define directly by formula. Okay. So Nusselt number is HD by K. Like this, do not define. So what is physical significance? You try to define by that way. So that will help you to remember in longer run. Because you may forget the equation, you may forget the uh, derivation, but you will not forget the concept, or you will not forget the what I can say, what is significance. Because though someone, if someone is asking, it is not necessary that he also remembers this equation. He wants to know why this equation are used, why these steps of equation are used. Okay. So fundamental of the interpretation of this equation is quite essential. So all the best everyone. So all the best for your exam. Thank you for joining all this session and help me to complete all this session. Hope we will meet with new courses in future, nearby future. Okay, okay. This means a lot. Thank you. Uh, okay, just